Hello friends, let's discuss today about the printing paste. In our last course, we had studied about the printing concepts, that how we are printing and which type of fabric, which type of machine is selected for printing. In this session, we are going to see that how one can prepare a printing paste specifically for printing, because if you see the dyeing, so we are just doing in a whole trough, we require so much of liquor, and the very small amount of dye we are adding in that liquor, and we are getting a specific shade. But in the case of printing, we have to fix that specific color at the specific location. And that's why in our last session, we had also discussed that printing is also known as the localized dyeing. So how that color can adhere at a specific portion, a specific design. So let's see that for specific location, specific position, we are selecting a special printing paste. And how to prepare this printing paste, let's see the detail about the printing paste. So printing paste is generally consisting the coloring matter, which is our dye and thickener. But if you are applying only dye on a fabric surface or any substrate, what will happen? Due to thickener, it will stick with the fabric, and when you are washing with the thickener, that color will also remove. So we require such a chemicals which are also known as auxiliaries in printing paste, which will help to penetrate the dye particle in fabric in situ, which will help to stick that dye at a specific location, which will help to create the moisture atmosphere. So these all functions will performed by various auxiliaries, and these auxiliaries required in your printing paste as per your dye. Like if I see the acid dye for silk, if you are selecting a dispersed dye for polyester and reactive dye for cotton, so which type of chemicals require for a which type of dye, that you can understand by completing this session. So these are the ingredients which commonly added in printing paste according to your dye. Like if I am selecting a dispersed dye, so I will going to add dispersing agent. But if I am doing with the reactive dye, then I will go for a hygroscopic agent. So according to the dye, we are going to select the auxiliaries which are listed here, like a weighting agent, dispersing agent, anti-forming agent, hygroscopic agent, oxidizing reducing agent, carriers, binders. After washing agents are also important, because when you are washing, you have to remove only your thickener, but you want to fix your dye at a specific printed location. Miscellaneous auxiliaries are depending on the variety of your dye and variety of your fabric and thickness, of course, because if I want to prepare, suppose C in this fabric, so I want to print at this location only, and the thickener will help to just entrap all the dye molecule at this specific location. So thickener is there, which will increase the viscosity of your printing paste, and viscosity is also again depend on your selecting machine. Like if you are working on a flatbed printing machine, then the viscosity is different of a same dye, same fabric, while you are working on a rotary screen printing machine. So let's see how these dyes, pigments or auxiliaries are functioning, and what is their purpose for adding in this printing paste. So if I select, of course we require a dye because we want to prepare a color, or we want to prepare an attractive design on our fabric. So we require a color, that is our dye. So what is the function of that dye? The function is attracting, just because we want to make it a beautiful, make it charming, make it attractive. So these all can be done with the varieties of color, and that varieties of colors are ultimately our dyes in case of textile. So those dyes which we require, again, which one which I had already told that we want to prepare a color effect on fabric and we want to make a shade. Like if I am just printing with a red dye only, but the majorly it is 5% shade, and somewhere I am using 2% shade, somewhere I am just outlining by 7% shade. So these are the various shade effect when I am selecting with a specific design. Okay, so these are the dye examples of dyes which we are generally we all are known about this thing. So the first auxiliaries which we had seen our listed auxiliaries, that is a wetting agent. Why we are using a wetting agent? So the beauty of powder, that is our dye particles. What is the beauty of that dye particles? If you pour a water particle or water droplet on that dye, it will not communicate with each other. That means they will not chemically react with each other. Same way, if you add the powder in water bowl, it will also just float on the surface of your water. Why? Because the surface tension of water is different. That surface tension will oppose to enter the dye particle in your bath. That is the work of surface tension of water, and which is a 696 dyne per centimeter. This is the surface tension of water. So what wetting agent is doing? Wetting agent is reducing this surface tension, so your dye particle can, otherwise you will see like this. And this is the second uh, glass is showing the function of wetting agent. So wetting agent will reduce the surface tension of your water, and due to this thing, the particles, dye particles can disperse in each and every zone. So let's see that how they are doing like this. Okay, these are my dye particles and this is my wetting agent. So now as your particles will enter, they will form a micelle and the particles will disperse in your whole assembly, whole container. So this is the working phenomenon of your wetting agent, that your wetting agent is ultimately surfactant, and that's why the upper portion is always water loving and below, that is the tail, is water hating. So this is the your fabric, and when you are printing at this, suppose I am printing at this location, the thing is what, that water loving group will be always opposing the fabric and water heating group will always attract it towards the dry fabric, because when we are printing, our fabric is always in a dry condition. Okay, so this particle will help to penetrate the dye particle till the in situ of your fiber when you are doing a fixation process. At that time the wetting agent will perform its duty. Okay, but if you want to help the wetting agent to perform its duty, you need another chemical which will give a water particle from your atmosphere, because when you are fixing, your fabric is in a dry condition, your printing paste is in a dry condition, and of course the atmosphere of fixation chamber is also dry. Suppose it's with super saturated steam or saturated steam or only a hot air. Okay, so these are the function of wetting agent which we had discussed, that to wet the fabric as well as dye stuff, though it will wet both, that means it will reduce the surface tension of both the thing, all which we had written here, to reduce surface tension of water, allowing the dye stuff for easy penetration into fiber. Smooth paste, that is of course our motto, and it will also help to dissolve the dye stuffs in the paste. And these are the example of wetting agent: olive oil, TR oil, that is a turkey red oil, castor oil, lisapol N, animal oil, and glycerin. Generally, TR oil, that is a turkey red oil, is widely used in industry when we are talking about the wetting agent. Now solvent, a dispersing agent or solution aids, all are a single chemical. And how they are working? Again, when we are dealing with the polyester fabric, we are only bound to select the dispersed dye. Now the beauty of dispersed dye is that it is always in a dispersion form. But when I am talking about the printing, I want that dye at a particular position, at a particular manner. So that's why I have to control the migration of dispersed dye, because the particle size of dispersed dye is very small. And as it is a small, due to the temperature, it will travel. That means it will migrate on a fabric surface only, and it will produce a thumb off, which is also known as the marking of effect. Marking of effect. Okay, so we do not want to produce this faulty printing. That's why your dye must be converted into micelle formation, and that can be done with the dispersing agent, which you can see here. This is our dye particle. This is the molecule of dispersing agent, water loving and water hating. Ultimately, dispersing agent is also one type of surfactant only. Okay. So when you are converting it in a micelle, your dye will be dispersed in your whole paste. Then you are printing the thing. Dye is dissolved in polyester fiber. This is the principle of printing the polyester fabric. Generally, what is happening in reactive dye cotton? They are forming a bond. Direct dye cotton, they are just attaching with the van der Waals forces and hydrogen bond. But when we are talking about the dispersed dye and polyester, your dispersed dye is dissolved in polyester fabric. That's why it is known as the solid colloidal solution. We will discuss in our further lectures when we are talking about the printing of polyester with dispersed dye. Okay, so your dye will penetrated in your fabric surface. That means the dye is dissolved in fiber, and then you will achieve the printing. Okay, this will reverse if you not control your temperature and pressure when you are doing a fixation process. So that's why when this will reverse, you will generate the marking of effect, which we do not want to require. Okay, so these are the function of your solvents or dispersing agent or solution aids to get a bright design. See, to assist dye penetration, which we had seen that it will form a micelle and it will dissolve in the fabric surface. To spread dye molecules evenly in the paste, which is ultimately dispersion. As a dispersed dye, we want to disperse our dye in whole area. Assist the dye fixation, that is again the dissolution of your dye in fabric surface. Prevent aggregation of dye molecules. See, as your particle size is very small, they will come near to each other and they will form the cluster, which is known as the agglomeration of dispersed dye, which can be prevented by adding dispersing agent. To prevent precipitation, of course, because when it will agglomerate, they will form a hard particle and they will come out from your solution. Increase the solubility of dyes, that is again the dispersion in the case, and to make a proper printing shape. Urea, glycerin, alcohol, desirable alcohol, acetone, diethylene glycol, that is DEG, and thiodiethylene glycol, that is TEG. For polyester or acrylic or nylon, we are generally going for a diethylene glycol. And when you are talking about the reactive dye with a cotton or natural, then we are going for a urea. So DEG, it is also written on your bottle, that is DEG 400 or TEG 400. Those are also used for the printing of synthetic fabric. Now let's talk about the deformer. Deformer, right now that is not that much important, but when we were dealt in history with a roller printing or anti-forming, deformer or anti-forming. So roller printing machine, when industries were working with this machine, deformer is most important chemical. Now why? So if we see that this is our, in a roller printing machine, this is the main cylinder, which is known as also membrane, and this is our color box, and the rollers are like here. What is happening that a small roller will pick up a paste, it will supply to the main printing roller, and this roll will going to print on your fabric surface with the stamping effect. Same way this thing is happening here. Now, as you can see in flatbed, the motion of your printing paste is very low comparative to roller or rotary. Rotary is also continuously moving screen. So what will happen when your printing paste is continuously moving? That is also known as the stirring. So due to the presence of surfactants, that is the wetting agent and solvent, these pastes will generate a foam, and that foam will come out here, and at one moment it will drop here. So if you are working here with a red color and here with the yellow color, after forming, this red color will come to the yellow color and it will create it as the orange. So to avoid this particular forming effect, either it is a roller or when you are dealing with the rotary, because what is happening in rotary, if foam is there, when you are printing at some specific area, you will find an air bubble, and that air bubble is also due to forming. So we want to reduce this air bubble. Also, we want to reduce this color effect, and that's why we are adding a deformer or anti-foaming agent in printing paste. So you can see to prevent the foam generation during printing. Silicone, deformers, sulfated oil, perminol KB, emulsified pine oil. These are the example of deformer, and generally perminol KB, or commonly known as the deformers, are used to reduce the forming effect which is due to the surfactant which we had added in our printing paste. Also, these deformers are added in polyester disperse dyeing in jet dyeing machine, because when you are moving your polyester in your dye liquor, they will also generate the foam, and that foam will give you a air spot on your dyed fabric. So at that portion in jet dyeing machine, we are also adding a deformer. Hygroscopic agent. Hygro is ultimately the moisture, and scopic, that is the agent which will carry, which will react with the water molecule, or which loves the water molecule, which is moisture, our H2O. Now, when you had printed your fabric, you had dried your fabric is in a dry condition, your printing paste is in a dry condition. When you are doing the fixation, your machine is also in with the steam, that is also a dry condition. But when we are talking about the textile processing, we are generally using the word textile wet processing, because when your fabric is in a wet condition, it will help to penetrate the dye particle into the fiber, because in the wet condition they will generate some zeta potential. Due to that things, your fabric will swell up, and your or maybe in polyester case it will vibrate and it will generate a blank space where your dye particle can enter, which is known as the penetrating. So dye particle, when it is in a dry condition, it cannot penetrate in a dry fabric. So we have to wet dye as well as fabric both, and that's why we are using the hygroscopic agent. This agent will absorb the moisture from your fixing chamber, and that moisture will help to wet your dry dye particle. Now this is wetting, and you can see this is cloud, but this is not what we want. This is what we want, weighted particle. And this weighted particle, your weighted fabric can penetrate, and you just take out your fabric from fixation chamber. Again, they will dry and water molecule will evaporate. Your dye particle will stabilize in situ of fiber. That is the beauty of this hygroscopic agent. So whenever we are printing the reactive dye, we are always adding a hygroscopic agent. Though you are doing that reactive dye on padding mangle, then cold pad batch bed, there also we are using the urea for hygroscopic agent, because that portion also we want to fix our dye at a very small time interval, in a very small time interval. So this is the beauty. You can see, to take up sufficient amount of water during steaming. Okay, what we had discussed. And that water is ultimately, in steaming process, that water is ultimately moisture. Okay. to enable them to transfer to the fiber. Of course, when your fiber is in wet condition, your dye in a wet condition, they both will help each other to adjust with atmosphere, and your dye will enter in your fiber. That is the transformation ultimately. And examples are urea, glycerin, or diethylene glycol. So now you can memorize two or three slides which we had discussed before this point. These are the chemicals which are also working as solvent, also working as dispersing agent, and also working as performing as solution aid. So when you are using a single chemical, maybe they can perform 2 or 3 duties in printing paste also. Oxidizing agent we require when we are doing with the wet dye, because the thing is that we are printing our wet dye in insoluble form only. We are not solubilizing our wet dye when we are doing a printing of wet dye. It is always printed as it's in a insoluble form, and then we are solubilize it at the fixation or development stage. But after development or after fixation, we have to produce our original dye, because when you are working with the insoluble dye, suppose this one is your yellow color, and when it is a solubilized, it will convert it into violet or purple. But we had printed the yellow color. So when you are selling your fabric in a market, you have to again convert this violet into yellow. So wet dye can be solubilized by reduction. We require reducing agent. So when you want to convert reduced product to original, you have to oxidize that thing, and you need oxidizing agent. Okay, you need oxidizing agent. So to develop the final color during steaming, of course, what we had seen, or to dye fixation. So sodium chlorate, potassium chloride, sodium nitrate, resist salt, ammonium chloride, ludigol, sodium or potassium dichromate. Resist salt or ludigol are both the same chemical, but the name is given by their company, and both are also known as mild oxidizing agent. And chemically, both are sodium hexa metaphosphate. Both are chemically sodium hexa metaphosphate. And the function of this oxidizing agent is also that when you are using a bleach fabric, pure bleach fabric, maybe due to the reducing bleaching agent, after washing that fabric, somewhere bleaching agent is there in your fabric which is not removed in washing exercise. So that zone, that particular portion of your fabric, suppose if you are printing this much paste and here the bleaching agent is still there after washing, so when you are printing at this particular portion, the color will reduce. So if this mild oxidizing agent is there in your printing paste, this mild oxidizing agent will react with this zone, and it will prevent your color in its original shade. So this is also the function. That's why in reactive dye also we are using a mild oxidizing agent, resist salt. We are also adding this thing to just prevent the reduction of dye at any portion where due to the mistake of your worker, due to the non-performance of your chemicals, maybe some portion is there in a reducing condition. So this will balance that portion, and you can prevent a shade of your dye. Reducing agent, of course, when we are doing a discharge printing, we have to reduce the dye, and at that time we are using the reducing agent. Again, if you talk about the wet dye or indigo dye, so though both are in insoluble form, but when we are doing the reduction, they will convert it into the hydroxide, and then we can convert that thing into solubilized form. So the function of reducing agent, see, used for reduction of different dye. Of course, that is the wet or indigo. Also, we had said that used for mainly in discharge printing. to destroy the color which is already on the ground and to make the insoluble dyes to soluble. Sodium hydrosulfide, very well known reducing agent, Na2S2O4. Sodium hydrosulfide, also known as sodium dithionate. If you referring an international reference book, you will see they are not writing sodium hydrosulfide, but they are writing sodium dithionate. So Na2S2O4 is sodium hydrosulfide and it is also sodium dithionate. Stannous chloride, when you are dealing with the color discharge, SnCl2, color discharge, we are using a sodium chloride, and rhongylite C or rhongylite Z, also known as sapholite or sapholine. Sodium rhongylite C is reducing agent used for discharging the color which are dyed on natural fabric like cotton. Okay, and rhongylite Z is specifically used for synthetic fabric. So rhongylite C is also known as sapholite. Rhongylite Z is also known as sapholine. Okay. So these are the name given by the manufacturer company which are manufacturing. They has given this name. Okay. So you have to just concentrate on your reducing agent. Reducing agent is how they are discharging the color. So suppose if your dye has azo group, which is showing red color. So this discharging agent will reduce this and this bond will be break. So now you have only single bond and hydrogen will be added. So as the color is showing by double bonded structure, when you are destroying one bond, it will ultimately become a colorless. That means your dye is already there on your fabric, but it is now it is colorless because of it has lose a single bond from its pair. So double bonded structure is converted in a single bonded and it converted into colorless compound, which is known as the reduction, where we are adding hydrogen and breaking a bond which is weak in double bonded structure. And that's why you will see the color, you will see the white image when you are just printing with the reducing agent, and you will see the color discharge effect when you are using the paste dye in your discharge paste also. But at that time you require a dye which is non-dischargeable. Okay. Now catalyst and oxygen carriers are very rarely used in printing paste, but when I am printing a pigment, so what is the principle of pigment printing? Suppose this is your fabric, your binder is here and here pigment is here. So this is pigment, this is my binder, and this is my fabric. So now what is the thing, if your pigment is only a surface printing, but to attach that pigment with fabric, you need a chemical which can bind both with each other, and your binder is in a white color. We can say that it's a white, but if I am printing a red, due to the binder, that red is converted into pink, but I want to achieve a red color only. So your binder must be in a transparent media, and that transparent media is produced at the polymerizing process, which is with the fixation chamber is known as the polymerizer. So when pigment printed fabric is passed through the polymerizer, the binder will polymerize and it will convert it into a transparent thin film, very thin film, and it will help to attach a pigment to fabric surface. So the binder at the right hand, if fabric is there, to left hand the pigment is there, and they will come to each other and they will form a bond and they will fix with each other due to the very thin layer of binder, which is a transparent layer. So to polymerize binder, you require a catalyst. That catalyst will increase the rate of reaction of polymerization of a binder while your fabric is passing through polymerizer. That is ultimately a fixation chamber. So you can see that it prevents the fiber damage. It accelerates the final color development, which we had said that to increase the rate of reaction, and reduce the risk of oxidation. This oxygen carrier is ultimately when we are in some dilemma कि the oxidizing agent will work properly or not. So for our safer side, we are adding oxygen carrier to prevent the thought of our mind only. Ki suppose oxidizing agent will not work or not perform very well, this oxygen carrier will help at that position. So copper sulfide, ammonium vanadate, potassium ferrosides, all are ultimately the catalyst and oxygen carrier which we are using when we are doing the preparing a printing paste. Acid or alkali, of course, to maintain pH. We all know if you are working with the reactive dye, you are going to add some chemical which will work as the alkali, and when you are doing with the nylon with acid dye, we want to add some acid which will maintain the pH of your printing paste. That will also help to develop the color when you are printing on the fabric. And in some cases, the alkali is the fixing agent. Like when you are doing with the reactive dye, your soda ash or global salt, both will functionize, both will do the maintaining help in maintenance of pH, and of course they will also help to fix the dye. The soda is there doing a fixation of reactive dye on your fabric, so that soda is also maintaining the pH, is also fixing the dye. It also help to creating a brightness in your color. So as per the fabric, as per the dye, we are choosing acid or alkali. Okay, generally we are choosing the organic acids because this is the printing. If you are using a caustic sodium hydroxide, what will happen at the fixation portion? If your sodium hydroxide is in a very strong condition, so they may damage your fabric. So at that time you have to dilute the concentration of NaOH. So instead of doing this thing, why not choose the organic acid like acetic acid, formic acid, or if you want to generate NaOH, just go for sodium acetate, okay, now, or potassium acetate, and then you can generate the alkaline effect when you are doing with the steaming. Okay, so you can see this soda ash, sodium bicarbonate, these are majorly used. Okay, organic acids, soda ash, sodium bicarbonate are majorly used in mainly in all the printing paste. Swelling agent, this is particularly required at the time when you are using or you are preparing a paste for synthetic fabric or fiber. Okay, because all synthetic fabric are very compact in that structure, and when you want to penetrate your dye particle in that compact structure, it is highly impossible. So that's why we are using some swelling agent which can help to swell the fabric at a particular temperature or pressure, and your dye can penetrate. Or now what is the thing is that when you are just running your synthetic fabric in a fixation machine at 175 degrees Celsius or 148 degrees Celsius, at that particular temperature, maybe your synthetic fabric will crystallize. It will generate a more crystalline structure. So at that time, we have to control the crystallinity also, and that can be controlled by using a swelling agent. So you can see that to create the big size holes of the fiber, that means it will swell the fiber structure, so your dye particle can penetrate. It will reduce the crystallinity, that means we want to control the crystallinity, and also help to penetrate the dye molecule in the fiber polymer. Why polymer? Because all the synthetic fabrics or fibers are manufactured by us, and those all are ultimately polymer, and most compact structure is polyester. So specifically in dyeing, we are also using the word carrier. Okay, so these carrier are why we are using carrier. Those are also ultimately working as specific case, they are working as the swelling agent. So the most commonly used is PEG, polyethylene glycol. Phenol is now it's not used because carcinogenic elements and it is banned. But polyethylene glycol, that is a PEG, is used. Diethylene glycol, diacetate is rarely we are just trying to do this with this chemical. We are generally using PEG only, polyethylene glycol. Carrier, what we had said about when we are discussing with the dispersed dye, polyester or polyester wool blend at 105 degrees Celsius temperature, because when you want to fix your dye on a polyester, you require 132 to 135 degrees Celsius. And when you go with a wool at this much higher temperature, the beauty of your wool structure, the natural beauty, the crimpiness will be lost. So you have to go for only 105 for wool. So when we are dealing with the blending, you have to use such a chemical which can prevent the original structure of your blend. That means of your fiber which we have used in blending position. Otherwise, the beauty of wool, that is the maybe a crimpiness, maybe the bulkiness, those all will be lost and it will become a flat fabric. So carrier generally diphenol, orthophenol, trichlorobenzene, these are the carriers can be used for in a printing paste. Now, some agents which we are added for a specific reason in specific paste only. So like which can assist the fixation of dye, which can absorb the moisture, and which can wash, prevent the washing off effect. That means when we are washing your fabric, the color will be just stable or stabilized on printed area only. That means they will not washed out. And of course, when we are talking about the fixation, we are talking about the moisture, we are talking about the washing off, we are only concentrating on hygroscopic agent or solvent. Those are urea and glycerin. After washing agent, this is the process which is required to improve the brightness of your color, to improve the fastness of your dye, and to remove the thickener which we had used in our printing paste. The most important thing, that is the thickener, because you want to just entrap your dye particles, entrap your chemicals at a particular position. Suppose if you are printing the R, so your color, your chemical, your thickener all will be at this R position only, and the rest of your fabric is white. But when you are doing the fixation process, this thickener will polymerize and it will form a brittle structure. So it will generate a very fine cracks on your printed yarn. So when you are washing, this thickener will remove and you will again achieve your soft fabric with the printed R. So to remove the thickener, to improve the brightness, that is a true shade, and to improve the fastness, we are using the after washing agent. And mostly non-ionic detergent, that is NID, is used in washing. Anionic and cationic are depend on a dye structure, but generally we are using non-ionic detergent in washing area. And now the main hero of our printing paste is thickener, because this is the thing which hold whole assembly. That means your thickener, dyes, your auxiliaries, your all agents which you had choose or selected for your particular printing process or printing operation. So this is the thing that the family, when we are talking about the family, a person who hold all the members at a same table, that is the main person in your family. Okay, like maybe changes according to somewhere the mother is there, somewhere the father is there. Same way in printing paste, the thickener is the main hero which hold all the particles, all the dye particles, auxiliaries, wetting agent, hygroscopic agent, oxidizing agent, reducing agent, which you want in your printing paste. Those all chemicals are just attached to this single thing, single chemical, that is the thickener. And this is the reason why your paste has some viscosity. This is the reason which will generate a viscosity. Okay, so you can see to act as a vehicle for carrying the dye onto the cloth, of course, and to prevent the spreading of the color on the cloth by capillary action. That means agar R print kiya, we had printed the R, the color is there only. It will not spread at any portion of fabric, because the thickener has just hold those dye particles at a location where I want to print. Okay, these are the examples: gum arabic, guar gum, sodium alginate, locust bean gum, synthetic thickness. We will discuss in detail about the thickness in our upcoming lectures, because we will going to do a single lecture on thickness only, because there are widely ranges in each and every thickness. You can see the modification also. Modified guar gum, modified British gum is also, modified gum arabica is also there. Sodium alginate is also somewhere working with the chemicals, and they will form a different structure. Viscosity of each and every gum, why synthetic thickness came in picture. These are all the things we will discuss in our upcoming lecture, where we are just giving the whole session to thickness only. Okay, so this is what the chemicals which we require in our printing paste. Hope you will find helpful for your study. Okay. And if you have any question, you can contact me on this mail, or you can also write a message on my blog. So here I would like to stop this lecture, and thank you very much for listening me. Thank you.